volunteering their time, and feel free to ask anyone in the room that has services to offer, about what they do, because we all like to work with people that we know and trust, and trust is absolutely critical, as you know, in this community. And I'm real pleased that we've got Bob here tonight with us, because I refer a lot of people to him. Definitely one that can be trusted when it comes to either referring you to the right direction or providing quality services for you. Okay, Roger?
Go ahead and have Bob start. I've got the
Bob, go for it.
video started.
Okay, I'm Bob Olsen. I'm a sales guy for Protogenic. Protogenic's been around since 1991. We started out in Boulder, and then the owners didn't like Boulder anymore and went to Westminster, and we've been there ever since. But we do what's called 3D printing now. Back then it was stereolithography. The machines were hundreds of thousands of dollars. Some of them still are. But 3D printing now is the ASTM speak for anything that makes parts with additive technology, essentially. So the opposite of additive technology would be subtractive, which would be
Machine.
yeah, right, machining parts.
CNC.
So, and the big difference would be, in machining you start with a big block of something, you take away everything you don't want, and you're left with a part. Additive technology just makes the part. So for things like that part there, if you can kind of show that around a little bit, when your geometries are complex, additive manufacturing is extremely inexpensive. To make that part by machining, you'd have to laminate the part. It would be very, very hard to do. To make it with additive manufacturing, that's less money than it would be just to make a solid block of the same material, right? Less laser time, less material. So that's sort of the power of additive manufacturing. Not only get a part, but you can make some very complex geometries inexpensively. If the geometry is simple, you're better off machining. It's more accurate, and you get better materials, right? So I've got a little presentation here, if I can figure out how to do it. Okay, now all I have to do is get this thing to come on. Anybody know how to do that?
It was working, right?
Yeah, it would look great. There, whoa!
Well, that's interesting.
Wow, now it's changed itself. So crane your
You
necks.
shouldn't drink before you do these presentations, though.
Well, actually, it came up earlier. Perfect.
Yeah, it was right. I saw
Right.
it. I'll
Anybody know how to?
Rotate the tablet.
Oh,
Hmm.
that's an idea. Try that.
Yeah.
Do what?
Just turn the
Try
tablet
try
on.
turning.
Oh, you have your
Oh,
lock.
other one.
Do you have your locked in?
Yeah, you got it locked.
Oh, jeez. But why was it okay before?
Oh,
Was
no,
it
that
laying?
says it's
Was
not.
it laying?
I think
How come it's not
it's
turning?
that way.
I don't
Okay.
know.
The other way, because you flip it to the bottom side, probably. If you keep turning the charger at the bottom left, turn it top side up.
Other way. Turn the charger
Plug
down.
the plug down.
Plug down.
Plug
Plug
down.
down.
Yeah.
There you go.
There you go.
Yeah, it really
No,
only likes.
it's not changing it though.
Yeah.
You may have to go out and come back in.
That is really interesting.
All these
Is there
smart
a
people in a
rotating
room.
control on the? Oh, maybe it's gonna update now.
What is this program?
It's Slide Shark, I believe it's called.
Okay.
Let's try it again here. I don't actually need this presentation.
It's it's checking, so I think it's got the right one now.
Aha!
There we go.
There it is.
So, Protogenic, after our owners got rid of us 4 years ago, sorry to say, they were great guys. I work with both of them. My background is tooling and injection molding. We worked for a company called Complex Tooling and Molding, and we were a $37 million company in Boulder. A damn good tooling and molding company. Unfortunately, our customers were Iomega, Compaq, Hewlett Packard, and they all went to China in the course of 2 or 3 years, and we went belly up. And then two of the people that had worked there had started Protogenic, and they brought me over in '98. So I went from tooling and molding to rapid prototype, and I've been there ever since. That's kind of my background. What we're going to look at today is just sort of an overview of what's available out there in terms of technologies. uh, what are the different types of RPs, what are the, you know, the strengths and weaknesses, the various technologies, and then of course a plug for what we do. So rapid prototyping, it's called 3D printing, but basically it's just taking a 3D CAD file and directly manufacturing a part from the 3D CAD file by creating layer upon layer. It's like taking a notebook and flipping the pages. By the time you're done, you got the whole notebook. You just keep adding layers till you got your part.
And that's pretty strong, is it? No.
No, it's not bad, but it's a layer technology, and so what happens is with all these technologies, if you've got a floor, it can be very strong, but if you got a couple snap features sitting up like this to hook something onto, and the layers go like this, they'll snap off. If you build the layers this way on a snap, they're quite strong. So with all these technologies, you really need to discuss part orientation and what's important to you in terms of the part function. And sometimes you can't get everything. That's a trade-off. The good news is, if your prototype works, when you go into production, it's really going to work well. Because prototype materials aren't nearly as good as production materials. That's the bottom line.
Bob, can you handle just about any 3D CAD software? Or is it just specific?
Yes, all this equipment uses what's called an STL file, which people say it's standard triangulated language or stereolithography. But anyway, it's an STL file, and those are outputs from almost any 3D CAD program now. Even really, inexpensive or free programs have plugins that'll do STLs. Programs like Rhino and stuff always give us trouble, but you get it worked out
So
somehow.
like SolidWorks AutoCAD, the basic.
SolidWorks is the primary package for design. People that work for big manufacturers, that's typically what they use. That or Pro-E. Industrial designers, the big picture, organic shape people, they have a lot of different really cool programs. They have a lot more difficulty creating a good STL file. So let's see. So basically, yeah, you can make anything. You can make unmanufacturable product with additive manufacturing. Stuff that's like this little, where's that little hoopty deal?
Back
Right here.
Right.
The knife.
So you can make that. It's like falling off a log, but try to make that with an injection mold, and
Yeah,
you
or
got some
CNC.
problems.
Is
Or
that pretty
CNC.
strong? Is that pretty strong like that?
I think so.
I was trying to break it. I was afraid I was going to break it.
Well, we have that file somewhere. I could probably make another one. The benefits of rapid prototyping, 3D printing, it's essentially you can put your product together and make sure it fits the way you think it should. Put in your printed circuit boards, put in whatever else you want. You can show your models to folks and say, what do you think of this idea? Picture's worth 1,000 words. An actual physical object is really pretty valuable to have. And that's what our whole business model is based on, is making parts to show people. You do accelerate product development. Like I mentioned that we did with Whirlpool, these duet dryers. You get all your marketing literature done. You get whatever else you need to get done before you ever get the real product off your injection molds or your metal dies and all the rest of that stuff. And you can directly manufacture product with using these technologies without any tooling at all, if the material properties are good enough for what you need to do in the cosmetics.
Basically, you're saying you would want to make a prototype with a 3D printer, but then more often than not, when you go to production, it's going to be some type of a mold type.
It's all volume based. We cast a lot of production parts out of these urethanes for companies like Endeavor and Boulder. They have these big, what they call the virusite machines. They test for viruses and things with these little samples. They sell 5 or 10 a month.
Right.
And they don't want to spend $500,000 on tooling to make these big parts. So till they build up their business, we cast them, urethane parts that are perfectly acceptable for what they do. Now, if you had to have a part that was out on a football field, like a helmet,
Right.
these parts wouldn't work. This kind of material wouldn't work. If it's sitting somewhere in a closet, if it's a rack-mounted bezel on a server, no problem. Right? If you need tens of thousands, go to injection molds. If you need hundreds, go to injection molds or thermoforming or some production technology.
So is that where the cutoff is? Once you get to hundreds, you should
Well,
be,
in small parts, you can go a long way without having a cutoff. In larger parts, we cast, like those big things we cast, they're probably $250, $300 each. So if you're doing hundreds of them, you could pay for a mold fairly soon, all right?
Probably
And,
like 3D.
you know, all you got to do is you get that 3D CAD file developed, right? Then you can quote us, you can quote the guy down the street, you can quote somebody in China. That same model is what everybody wants to see to give you a quote for production, prototyping. So then you can do your Ben Franklin.
But it's a different kind of file for just prototyping than for
No,
injection
the
molding.
basic CAD file is the same for everybody. The output, we take an STL file to build stuff, but that's a file save as, right? You take your main CAD file and just say, please save this as an STL this time. And if you send it to us, that's a great thing to send to us. If you're going to send it to China for a tooling quote, just send them the native file.
Really?
But it's the same file.
Oh,
The STL file is just an approximation of your geometry. It lays triangles on your surface areas. And the smaller your triangles, the more accurate it is.
That's actually makes the layers.
Yeah. Yeah.
Gives the direct instructions to
If you have large triangles, holes look like octagons. And the more triangles you get, then they turn into, and that's just a quirk of the stuff that was developed back in 1996, 97. I'm sorry, 86, 87 by 3D Systems. If you did it today, they'd have something completely different.
Okay, I
But-
didn't understand.
So, parts can be used for fit, form, function, marketing samples, prototype production, low volume, education. There are four major types of 3D printing. Protogenic has three of them, and those are stereolithography, the nylon sintering, the Connex multi-material printer. This is an inkjet printer that jets out just like the inkjets you have at home, except these shoot plastic and they solidify. You just keep going over till you develop, a 3D part.
And it adds pigments in the process?
This particular machine does. So other people build inkjet printers that don't have the same kind of colors and can't do the multi-materials.
Sure.
So this particular, this is not a useful part, by the way, since no injection molding machine could have, well, some of them are up to 3 or 4 barrels now. But essentially it has two parent materials, a soft material and a hard material, and it can print them both at the same time. So if you want a toothbrush with bristles and a soft hand, a hard handle with a soft grip, it can do that as one build. So it's really cool in that respect.
But does it all start as like a neutral base material and then?
No,
add
you
it?
can start with a white material, a black material, and there's a green material.
Okay. And can you take?
And a blue.
If you wanted? If you wanted to add pigments?
No.
to it,
They
then-
come in sealed cartridges.
Oh, okay.
Very expensive material because this company that makes the
It's
printer,
like
they're the only ones that make the razor blades.
the HP metal.
So it's a great model.
Do you guys do metal, sintered metal?
We do not. I can discuss that. There's several machines in Colorado now that do print metal. So there are 3D metal printers as well. They print stainless steel, A6, titanium, cobalt chrome. Medical modeling, which is very close to here, has EBM machines, and they'll take an MRI of your shoulder and they'll create you a custom metal joint.
Same with the
Yep.
plastic, are those as weak as?
In the case of metal, they are 99.9% dense. They're every bit as good as cast metal. It's a different process. It's much higher heat,
Right.
and so their melt puddle is way better than what you get with this technology. So it's EOS builds our machine, the laser center machine. This is only 92% dense compared to an injection molded product. So it's got porosity. In metal, it's 99.9% dense. So there's no room for air in that particular technology. So it's really cool. And I'm sure I probably have a metal piece here if anyone wants to see one. I'm sure I got one in my bag somewhere.
So the way that it attaches metal particles is through a process of heavy or high intensity heat.
Yes,
Is that a laser or something?
yes, it's a very strong laser. I can't remember their yttrium something lasers. Our laser's a 50-watt CO2 laser.
Okay.
So, and I'll go through the process a little bit quickly because you just come over to the shop sometime. Speaking of the devil, come over to the shop sometime. We're happy to show you the machines. But so SLA is a vat of UV curable epoxy. You bring a tray up, you build a support structure on there so you can build your parts on top of the support so you have some room to cut the parts off without damaging them. And then basically you've got a 13 thousandths, an 013 effective beam spot that hardens, wherever it hits the epoxy, it hardens it. So, and so we get lots of customers that send us this big block of stuff. And it's got a couple little neat features on the outside. We go, just make that block out of anything. We'll make you the neat features and put them on there. Why would you want to spend a bunch of money with a little tiny laser hardening very expensive material? Yeah, we argue with Ball all the time. I mean, they bring over these big, huge things, and we go. And our machines harden maybe 3 cubic inches an hour. So if you get a 400 cubic inch part in there, just the hardening time is a lot. Let alone you got a recoat after every layer. They build in 2, 4, 6 thousandths layers. So it gets on the layer that the platform will drop down, and then you get a Zamboni blade. It'll come across and re-level the resin. Then it goes again. Well, that re-leveling takes between 30 and 60 seconds. So if you have a 10-inch part that's like 2,000 layers times 30 to 60 seconds, you should be building something cool if you're paying money for that, not just a solid piece of something, right? So most of us will tell you that. A lot of people just give you a quote and you'll go, God, that's really expensive. Well, you're not using the technology really as it should be used. I should probably have some samples of that, but that's how SLA works. It's really fun to see them run. They're pretty cool machines. You see the laser, phosphorescence, if you will, on the surface of the material. It's kind of cool. Laser centering, you have a chamber you heat to 350 degrees. This is for the nylon. So it's very close to melting temperature of the nylon, and you spread powder out. And then we take your CAD files, we slice them into, they're all slice files. We slice all your geometry into layers, and then we relaminate the layers in the machine. So you take that first layer and you melt the nylon powder, drop it down 5 thousandths of an inch, spread more powder over the top, heat that up, and then melt the next layer. And you keep going down until you've done all the slice files and recreated your part, and it's sitting in a hot cake of nylon. And then after that, you wait till the nylon cools down, and then you go pull the cake up, jack it up, and start looking for your parts. So it's kind of fun. If we're building a lot of small parts, we'll just build a box around them. Doesn't cost us much. We hit the box, we go, that's where all the small parts are. And we start looking for them. Rather than just have them sit around, all over the place, and you may or may not see them.
Are they like attached then, like with a little riser or something? The small parts.
Oh, they could be. They could be anything, right? They could be little. Yeah.
So you don't lose them; they're all attached to the box.
They're not attached. They're sitting in a cake,
Oh.
but they're surrounded by a hard box. You find that box, then you can get rid of everything else, dump that cake out, and look for your small parts.
Oh.
Wow.
So they're all in. And
Because it's all that nylon powder that didn't get sintered.
see that clamp right there. So you can open that up. That's a fully functioning clamp. It's actually a miniature clamp of what the machine makes for itself. So that holds hoses and whatnot. You can build that as a single part file because it's a powder support system. You just, in your assembly joints, you just leave a little gap, work that powder out, and you have a working assembly without ever having labor or anything else. That's what's cool about that technology.
So that's how they do the balls inside the cage. And
Right,
stuff.
exactly.
Okay.
Yeah. So as designers start thinking outside the box, as materials get better, then people talk about customization. You can make 5 products for you, 5 almost the same products with different features for you, and there's no tooling chains. It becomes a very cool technology. And I'm sure in our it's going to happen right now. We will eventually have stuff in our garage. We'll just dial in a catalog number for an auto part, and it'll make it. Auto parts stores. A lot of people are going to be in trouble in the future. Our company, there's a ton of little 3D printers out there, little $1,000, $2,000 3D printers. They're eating our lunch at the low end.
Yeah.
They cool
have
stuff.
Their inventory comes over the internet.
They have one up at the Loveland Library.
At the
Yeah.
library.
Yeah, at the library.
Well, Kinko's or somebody's going to put them in. You know, you could make your color copies, you make your 3D copies. So it's happening. It's pretty cool.
I think I saw where
Unless you're in the business.
somebody, I don't know,
Yeah.
in the last year or a few years, made a storefront that's just for like
There's a
3D
shop in
printing.
Aurora called 3D Printing.
Okay.
A friend of mine's opened up a shop this way, Jeff Zepp.
There's one in Denver.
There's one in Boulder right now. Print shop.
Incredible.
Yeah. Now the trade-off, of course, is materials and resolution.
Right.
But you know, for your first couple models, stuff's good. Nothing wrong with that. Fused deposition modeling is the fourth major technology. We don't have that. It's really a very cool technology, and most all little 3D printers are based on this technology. And essentially, you take a fishing line and shove it through a heated nozzle and you draw the part. So it's real thermoplastic. You can get really cool materials like Ultim or Peak, which you guys probably mostly don't know those materials, but they're very high end, $9 a pound up to $20 a pound type materials, but they have really cool properties. Heat deflection values of 400, 500 degrees F, that kind of a thing. Great, FR, fire retardant properties and so on. So this is a very cool technology, and this is the most dominant technology in the marketplace, fused deposition modeling. A company called Stratasys has started that thing. And I
With
thought I brought a sample, but I don't see it.
with a smaller printer, well, like it could be smaller, it could be bigger. What you were just the fused deposition. Do you have the same strength that you might with something that's made in the different processes that you spoke before
The
this?
problem, all these technologies have trade-offs. They have strong points and weak points. FDM's weak point is they use a specific diameter of plastic. So say it's 10 thousandths on one of their larger, faster machines, and you're building a wall that's 25 thousandths. It doesn't fit. So you got to kind of create these hollow spaces. And then on snap features, it's the same problem with nylon. Like our nylon, if you're building a snap feature this way, those layers, the adhesion between layers isn't very good. By the time it gets back around, everything's kind of cooled off. And so the adhesion between layers isn't great. On a wall, they'll go like this the first time and like this the second time. It's very strong and very good. But on smaller features, they
Right.
start to break pretty easily and that sort of
I mean,
thing.
If you're building something like this, you've got,
Yeah.
there's not much holding on to each layer going up. But
Yep.
like you said, if you turn that part over, you've got a long run.
It's very
of
cool. The cosmetics aren't as good as like SLA. So when we do these master patterns, FDM wouldn't be a good way to start. It'd be like using nylon. You can't sand it down because it doesn't fill in. It is what it is. They're these strands, so they don't fill in when you sand them. And nylon won't either. You actually have to put like Bondo or primer filler on it to actually make it look good. And that's just a lot of work.
It's tedious.
So people that are in the business of casting don't use those types of equipment for patterns. But it's really cool technology. Laminated object manufacturing, we're going to skip. There's one company out there still doing that. It's really a cool technology, but we're going to skip it. Objet is 3D also has a technology. They're called projets, but they're just those inkjet printers, and they're pretty cool. They're very fast. They're more accurate because they have a traveling head than other technologies, as opposed to we have fixed laser that's reaching out into different areas. But the material properties are crappy. They're not very good. Sorry to say. There's one material that machine makes. It's called Digital Material 5160. It's really good, but everything else is worse than SLA. The one cool thing you can do in those machines is you can make elastomeric parts, and it's the only technology that's very good at that. So all the other technologies just make hard materials. There is one material you can laser sinter that's soft, but I don't think they sell it in the United States anymore. I don't know why.
So is that how you made this?
Yeah, so that's an inkjet printer, and it'll print both the hard and soft materials at the same time, as you can see there. And then there's a ton of 3D printers out there. You name it, they got one. See, current trends, just material improvements. way wider adoption of 3D printing. You know, in the last 12 months, it's been an explosion of information about 3D printing. You can't open a newspaper or an email without seeing somebody doing something with 3D printing. They're printing organs, they're printing you know, biomatrices to implant in your body to heal things up. They're printing buildings. That guy in Southern California prints buildings with a concrete plotter.
Jeez.
Yeah, it's amazing. They're printing parts of automobiles. Plastic and metal printing is really big in Formula One racing because they can replace parts. The Army, rather than carrying a bunch of inventory over in Iraq and Afghanistan, they're putting these things in trailers, these printers in trailers, and making their parts. They're punching up the catalog numbers and making parts. You probably read about they're going to put that 3D printer in space.
Mm-hmm.
So trip to Mars, you don't want to carry a bunch of inventory for broken parts, just bring a 3D printer. But they have to see how they work in space. That might be a little tricky.
Mm-hmm.
uh,
No gravity.
So, and then direct metal laser sintering, we touched on that briefly. The name for it is DMLS, direct metal laser sintering, but there's actually 3 different technologies out there that are different. The result's pretty much the same. But General Electric, your old company, Bonnie, just bought the largest service bureau that does direct metal, Morse Technologies. And what they're doing is, they've already done it successfully, they're taking their engine jet nozzles and turbines, and they're combining parts. So rather, they've combined, I think, up to 10 different parts into one build. So it's stronger, it's faster, it performs better. And if you're in the aerospace industry, we do a lot of work for people like Ball Aerospace in Sierra Nevada. You got 10 pounds of paperwork for every pound of part. If you can get rid of 8 parts and just make it one part number, you have saved your QC department a ton of work. And they say Boeing has had 30,000 parts they make for their aircrafts out of nylon, and they have not had one failure yet. You think about this, duct work, it goes like this. Rather than making 4 pieces and putting them together, they just grow one piece. It's just fantastic. Beautiful stuff.
And it's cheap enough that they can do that.
Yeah, oh yeah. It's way cheaper than actually manufacturing a whole bunch of parts and assembling them. So that's kind of the cool thing. People are making molds out of this stuff. Yeah, it's not interesting. What does Protogenic do? We do stereolithography patterns, we do nylon laser sintering, we do the Connex inkjet printing, and then we cast urethane and silicone parts, so you can see those. And those are essentially, if you want a higher end model, then we can help out. Lower end models, like I say, if I were you, I'd go to these 3D print shops and get the first couple made there. It's going to be less expensive. It's going to give you a great idea of how it feels and how it looks. If you want to take something to QVC, and a lot of our customers go to QVC to sell their product, then you need something that looks really good. And that's where we can help out. Those are what SLA machines look like. But again, you're welcome to stop by and see the... I don't think any of this stuff's particularly interesting. Well, we touched on this. You can go through every technology and it has strengths and weaknesses. So when you go to get a model made, it's important that you ask your service provider, look, here's what's important to me on this part. I want these snap features to work. This thing's got to hold 50 pounds. My part has to withstand 250 degrees F on a continuous basis. You've got to tell them that. Otherwise, what you get may not be at all what you wanted. So you've got to have that kind of conversation up front. They can tell you what the best orientation or the best process is for what you're looking to do, and they'll also tell you, hopefully, what's not going to work and what's going to work when you build your model. Because sometimes you just can't get everything done. You go, hey, it's a prototype. If it works for you, it's really going to be good when you go to production, but if it doesn't, sorry, that's just the way it is. And again, all of these should touch on, we have on this slide we call it direct manufacturing. It's really called, ASTM now is defined as additive manufacturing, and that's when you use one of these processes for production parts. And that, for example, was a production part for a customer. He only wanted a couple hundred of them, and it was way less expensive just to build them in nylon, and the material properties worked fine for what he needed. It was an internal part, nobody saw it, cosmetics didn't matter. It did have to withstand quite a bit of heat, and nylon goes up to about 350 degrees on heat deflection. So there's a great potential for additive manufacturing with these technologies, and that's probably 25% of our business now is low volume manufacturing using nylon or these cast parts for customers. So that's kind of cool, and that's actually a direct manufacturing example. Those are the hoses on the machine that it holds. The clamps are actually this big. We scaled them down because we didn't want to spend money printing them. This is that centrifuge I mentioned we do for Terumo blood components technology. We replaced a hard aluminum part. That's about 8 inches tall and probably about a 6-inch diameter, something like that. So we sell those for $800 and some, but it's way less than hogging out a bunch of aluminum and finishing it. Oh yeah.
Cost effective.
Oh yeah.
Sure.
Especially a couple of years ago when commodity prices were really high. So I don't think any of this stuff's much very. There are, with all these technologies, there's different resolutions, and this is a little hard to see actually. But the polyjet, the inkjet's on the right side. So on a gear tooth profile, you're splattering droplets and then hardening them. It's not as good as a solid laser creating your geometry. So if you need a gear drive, for example, that may not be the best technology to pick. And those, again, just you got to have those kind of conversations when you're talking to it. It's faster and more accurate, but it's not as crisp in terms of small detail as you get with like SLA.
So those are two different printing processes?
Yeah, on the right is the inkjet, and everything's rounded off. You can kind of see on the
Okay,
top.
yeah.
And on the left, it's a solid state laser made those in a SLA machine, and they're very crisp. And we could go through all that stuff. That's enough. That's enough for the presentation.
Process, if I just bring you a file, you can make a mold from the file?
No, well, you can, yes. The answer is yes. You wouldn't want to. So what we do is we take, if you can do that green part there, we would simply 3D print a part,
Okay.
and then we sand it up, maybe spray a texture on it, hang it in a box, put a bunch of vents and a gate on it, pour silicone all around it, cut the silicone open. Where's that silicone mold?
Right behind you.
There you go. There you go. So that'd be the master pattern. We make it look really good, hang it in a box, pour the silicone around it, cut the part out, and now we've got a mold that we can pour urethanes into and make part after part. Now these molds only last for 20 to 30 parts before they're no good.
What's
But it looks like they're cheap to make.
Yeah. You can do this at home.
Right.
Oh yeah. You won't get great results, but you can do it at home.
what's something like that
And there's
cost?
I would say we would charge $650 for this mold. The pattern would be $200, $650 for this, and cast parts would probably be $50 each.
Okay, so
look
you
at the
gotta
really
show
short one.
cost effectiveness there.
Short run. Yeah, they're very cost effective if you got to get to the hardware show in 3 weeks and you don't have anything to show.
What would be the next step, quality step up?
Well, after that, typically you would go to injection molding. And of course,
Is that a mold made out of some aluminum?
well, it would be plastic injection molding, and within that category, there's at least 5 different classifications of tooling that you'd go to. So if you go to injection molding and go, I only need 500 parts lifetime, that tool's going to look very different than if you said I needed 2 million parts.
Yeah.
You know,
Yeah.
with hardened
That cost
steel,
effective.
EDM, these would have hand pick outs, and you know the part cost would be quite a bit higher, but the mold would be very cheap, up to the fully automated, very expensive mold, but cheap parts. So
And a
very,
A very expensive mold would last longer than 20 or 30 parts.
hopefully,
I hope so.
hopefully, but that would typically would be the next step. There are we have done work with Value Plastics up in Fort Collins and some other folks where we're actually making SLA mold halves, and then they'll put in some features, some core. Value actually metal centered a metal core, and we put in conformal cooling lines in our SLA, and they made at least 20 or 30 plastic injection molded parts before the stuff gave out. So there are ways of getting quick, real material parts for testing using these technologies as well. So again, simple geometry helps in that particular application. If you had a fine detail, the injection molding press would just snap it right off. You know, they're not great materials. But any questions or?
Is there some way you could learn most of the properties of this stuff?
Or we should just come with what we want to do and answer the-
Well, if you email me, I'd be happy to send you our, I don't know how many pages it is now, I think it's 14 pages. 14 pages of stuff. And it'll tell you, you know, what inserts you can use. It'll tell you what the mechanical properties are of the various materials. It'll tell you what tolerances we can hold. And these tolerances are fairly typical of the industry. You know, for example, on SLA, we're only going to be plus or minus a thou to a thou and a half inch per inch on your model. So you have a 10-inch model, we could be as much as 15 thousandths off geometry. So we work with Covidian, for example, is our biggest customer. I don't know if you guys know them. They're a medical device manufacturer in Boulder. Sometimes they need tighter tolerances. You can get them, but you got to run models at least twice. So we get your model in, we set a scale factor, and we build it. If we're a little bit off, we can tweak that in.
Bob, do you have that, is there a link on your website that we can get to that?
I think there is, and that's a good question.
Because if you do, then we could put that on our website so that we can allow people to go to that.
Yeah, it's protogenic.com, and I will double check that, and I'll be happy to send you the package in this electronic form. And it
That'd be
actually is
great.
a little bit interactive if you get the electronic form. You can click on things and get there faster. So, yeah, I'll get back with you on that, Bonnie. And most websites, either for the manufacturers or for the service bureaus, will list what materials they use and what their mechanical properties are. You know, for example, we have one material that's about as good as ABS, except for impact strength. So you could go down to general purpose ABS and compare, you know, tensile strength, tensile modulus, elongation to break, and you can say, oh, this compares fairly favorably to ABS. I want to make an ABS part. This could work for me for testing purposes. Most of the materials aren't as good as thermoplastics. These are thermoset materials.
So if I come with some prototype, like I made out of clay or something where I don't have a CAD file, but I have it,
Mhm.
can you scan that, or how do you?
We don't scan, but I can certainly give you the name of scanners.
Okay.
No problem at all. You know, 98% of our business, people email us files, we email them a quote, and they say go.
Nice.
It's kind of weird. We never hardly ever see our customers. It's kind of weird. But
So, can you patent a 3D CAD file, or is that?
I would defer to Roger on that. I really
Okay.
have no.
Yeah,
Now
just
you've copyrighted.
copyrighted. Okay.
Oh yeah, you
Yeah,
do
'cause
NDAs, right?
You go to sit, well, you could go to whatever Asian company with a 3D CAD file, and you know, I know they like to knock off ideas a lot. You know, they can just take your idea.
It's getting better. When I went there, my last trip to China was in '96. I was still with Complex Tooling and Molding, and we were doing work for a company called CD3, and had a really cool, wouldn't sell now, but it was a CD selector. So it was a round box. You could put like 100 CDs in there, and it had this little thing you
yeah.
could zip
Yeah.
along, and you go to your
I
one
remember
here,
that.
you'd let it go, and you'd open it up, and it'd pull the CD out. Well, the second they started shipping product here, the product appeared in Asia as well. And they weren't sure if they built two sets of tools or if it was one for you and one for me. And they went after them, but it took them years and years and years to get any resolution on that.
Okay.
It was terrible. And China's a lot better now because the United States has, the tool engineers here have educated them how to build stuff and how to do things. They're really good now. When I went there in '96, I've got a whole album. I should have brought it. All the good mold makers had all the crap equipment, and all the government shops had the really cool stuff and didn't know how to use it. So I don't know if you guys know what a sprue bushing is in the back of a mold, where you put the nozzle on from the machine and squirt plastic in. You just make a hole and you install a spec sprue bushing you can buy from anybody. Over there, they had to put it on a drill press, drill 50, 100 holes, and then just knock the son of a bitch out, and then stick this thing in. because they didn't have the equipment. They had no way of drilling a big hole. It was unbelievable. We were like in a state of shock, and every day at 4 o'clock the shop went, the electricity was turned off. And we went over there and we went all through all these specifications. We need this kind of tool steel. We want you to use Udo Home. We did, oh, yes, yeah. They came back, it was soft steel, it was absolute crap.
Yeah.
It was absolute crap.
Yeah.
Yeah, I mean, that was my concern was, they say.
That's not the way it is now.
Well, yeah.
Believe me,
but
there's some very, very good shops over there. Sorry to say.
if I know how to do 3D CAD, or I get somebody to make my prototype or my drawing, and then I take it to said shop and then just go, well, I mean, I guess if you don't go into an agreement with whether it's your company or somebody else that says, you know, you can't steal my idea and I don't have patent pending on it because I don't have a prototype yet, you know.
There's no need to have a prototype to file for a patent. I mean, I've seen a lot of people come to our shop with their patent already done, and they've got it all sketched out, but they don't have any 3D CAD file, and they never did.
Right.
So that's not necessary.
Okay, I didn't.
You can put it in
Again,
and
I'm so
just
new to this.
write up the text, and then you can refine it later. Because it's usually better to have something not exactly right in, and then refine it later, especially these days when there's a lot.
Costs more to refine it.
Costs you more in the long run, but we usually better protection.
Plus, you don't know at first exactly how it's going to work out. And that's what-
Right, you're always going to be tweaking that design, so just assume you are. The other thing you use is confidentiality agreement.
Hi there.
between
What if
the
I
two.
bring you a
At least you have a
sample
contract.
of something that's already
Give me
made
something
out
to
of
laugh at and say,
plastic, but I want to
"Right, yeah,
modify
right."
it to do something entirely different than what this product is doing. And I need to have, in the plastic handle, I need to have a cord for a battery to go down to a switch.
Mhm.
Everything.
We actually don't do engineering work. What I would do is I'd say, look, here's 3 people that can do that for you. Go see them. And they would create the 3D CAD files for you that did exactly what you wanted.
Yeah, but I want to change the function of what it.
They
Yep.
would change it.
But they would just simply take what you've got and then create that in the ether in their little CAD packages.
Okay, and then what do they, do I bring that to you to actually make a sample?
Yep. You can email it. You can bring it in. Like I said, you can email it to China and get a quote. Once you've got it in the 3D CAD file, you've got something you can talk. That's the universal language. You can machine it. You can injection mold it. You can prototype it. I think nobody I know works off 2D anymore,
Yeah, those are the never public
Did you
language.
say you could do
So-
unless it's a 2D
And
part.
a
Waiting
card?
for them to give me
And a card,
dates.
business
Actually, I
card?
do.
The instructions,
Business cards?
but it should be next week or two.
So if we just look up photogenic on the web.
What do we, to kind of explain to you what I'm trying to do, what do we, sign a non-disclosure?
Oh, yeah, which.
Yeah, and we have a mutual non-disclosure I can send to you, and you can modify it to your heart's content. If you've got one, we'd be happy to take a look at that.
These guys are good.
99% of the NDAs we get, we sign. 1% we reject because we get stuff like, we had this one guy who's building some sort of garage door stopper or something. He goes, you can't do any work for garage door stoppers for the next 3 years for anybody. And we go, you know what? 90% of the parts we look at, we have no idea what they're for. We can't sign this in good conscience. Every part could be a garage door stopper. You look at the stuff, we look at 100 parts a day, and you look and you go, and I don't have any of them out here, but most of the parts we look at, we go, well, this silicone part here, for example, you go, well, it's channeling something. I don't know what, right? I don't know why that one thing comes off at an angle and the other one. So we don't know. Those are the only kind we reject when we go. We just don't, in good conscience, we couldn't follow this. We wouldn't know how to do it. And boy, we see some weird parts. I mean, really weird parts.
You don't want to
Okay,
know what they're
so-
for.
Sometimes. we're doing a really nice bowl for a guy, and it turned out it was a bong part of some sort.
Uh.
I don't know. We didn't know.
That stuff's legal now. So yeah.
That's in Colorado, I guess, yeah.
Okay, I see your website. You can just request a quote, so they just send you CAD files. And
Yeah, you can, there's an FTP or something you dump a CAD file on. I don't spend much time on our websites. We got sold in May, and we had to develop a new website right away, so it's not very detailed yet.
So do you have connections to people that do 3D CAD drawings?
Yeah, a lot.
Okay.
A lot, from simple drawings and low cost to, you know, the Boeing 747s and high cost.
there's a guy who comes here who doesn't. He's easy to work with.
Oh,
What is
So
it?
would
You
the
know who
best
guy's
thing
name is,
to
Larry?
do,
Oh, Langston?
Langston? Okay.
McDowell's.
SolidWorks.
Yeah.
Mhm.
would the best thing to do would be bring my sample to you to look at, and then you direct me, and then,
You could do that. You could email me a picture of it and say I need this modified, and I'll email back some designers that can do a good job for you. But you're welcome to come in. I mean, 90% of the time I'm in the shop. We're just a little west of US 36 on 104th Church Ranch.
Where was it? 104th and what?
Church Ranch.
See that
Yeah,
as
that's-
We're about a mile from the Butterfly Pavilion, west of the Butterfly Pavilion.
Yeah, I know where that is.
You know where that is?
Yeah, we live in Brookfield.
Yeah, you're close.
120th and Charlotte.
You're very close.
Yeah.
You go out to those faux places that are there all the time for lunch. Those 18 faux places.
Oh, yeah. It's
Any other questions for me? Start packing up?
About the, on fillers, internal pieces.
Yeah, we overmolded a polyethylene tube.
Mm-hmm.
That was for mine safety. They used to be out in Denver, and they're back in Pennsylvania now. It's too bad. They had a really nice shop out here. But that was I remember that product. They had a strap that went through, and they used that to hold chisels rather than holding chisels like that.
Mm-hmm.
So it was a great safety improvement just to hold that thing with a strap.
Should like put metal or anything else.
Yeah, you could put anything you wanted in there. We can overmold. Anything you do in injection molding, we can do. You know, like that, that's an overmold as well. But you got to be able to hold and pin the undermold, that's all. And that's there's a couple shops in Denver that prototype magnesium, aluminum, that kind of a thing. And we often, for military hardened computers, they'll do the magnesium, and we'll do the rubber overmold on the outside, that sort of thing. And I have a database that's pretty impressive, so if you need something, typically I've got somebody that can do it.
We were just getting here when you were talking about the one part that has the, is it metal overlay or urethane?
Yeah, it's a bright chrome.
Okay. And that's just a coating that adheres directly to your.
It's a little hard to metalize prototype parts, but where's that other piece? Basically, what you do is, as you probably know, it's hard to plate plastic.
Right.
So what they do is they spray the plastic with electrose nickel, and then they use that as the attractant. Then they'll put it in the bath.
Put a charge on it.
Yeah. Then you put a charge on it. Then they'll put a veneer copper on it, and then you can do whatever you want after that. Typically, people put on a couple thou nickel, because then you get a lot of strength, and then you can put on bright chrome or whatever you want.
See, I thought that was maybe similar to like a powder coating with the metal 3D printing that made it
You can vacuum
charge it like
deposition.
that.
Somebody mentioned vacuum dep earlier. You can also, I don't know if you're familiar with vacuum dep, but it's basically you put a block of aluminum here and you vaporize it and shoot it at the part. It's a line of sight process. You have gold, silver, aluminum, and you get some really cool finishes. And it's not, it's tenths of a thousandths of metal, so there's no weight at all added to your part. This doubled the part weight.
Yeah.
Plus, you got to plan for these dimensions. This particular part added about 13 thousandths per side.
Yeah.
So if you're doing an assembly or something like that, then that's very important
Yeah,
to
you gotta
have those
know your
conversations
clearance.
before you launch.
Right. What is that for?
That's for a company called IGT, International Gaming Technology. We do a lot of work for the gambling industry in Vegas, and they like glitter. Everything they've got shiny.
Is that going on?
Slot
It was a slot. It was on
Yeah, it
something
looks
on a
like-
slot machine.
Like where the coin slot would come up through the middle.
I have no idea. Again, if you're making this part, you go,
You don't know
Yeah,
what
well,
yeah, I signed a non-disclosure, but hell, I wouldn't know what to tell anybody anyway.
Put ornament or what?
Incidentally, if you look on the back side of this part, you'll see the layer technology.
Uh-huh.
So this machine built in 6,000 layers, so we don't sand that off. So it's an actual physical step up as you're going across a radius. And to make the parts look good, you got to hand sand them. There's a lot of hand work in the shop.
Really?
Oh yeah,
Well,
a
I
lot
guess
of bench
one
work.
else.
So the other side of the part looked just like that, but we just sanded it down.
Yeah, okay. Oh, all right. So yeah, the outside had that.
Right, same steps.
Wow, that made a big difference.
Do you work with titanium? Do you work with titanium?
We don't do anything at all with titanium. You can get titanium parts made with direct metal laser sintering, no problem. TiO6, I think it is.
That's what my hip is.
Cool. Well, titanium is extremely cool.
Ceramic.
So, who made your hip? Do you know?
Amos out of Switzerland.
Oh, I'm not familiar with
Yeah,
that.
I have a titanium rod, ceramic ball, and 2 plastic cups.
Oh, nice.
And I have to have my other hip done December 30th.
So was that a custom implant or was it an off-the-shelf?
Well, my doctor, he's peak orthopedics surgeon. He does his surgery at Skyridge, and he teaches doctors all over the country. It's an anterior incision, so it's less invasive to muscles and nerves.
See, people like Depew. Most orthopedic manufacturers have like 6 different sizes, and you fit into one of those categories. People like Medical Modeling and Golden take your actual MRI X-ray data and create exactly a custom hip
Nice.
that's exactly what you've
Wow,
got.
That's great.
It's expensive,
Mm,
but
Sure.
Right now,
but it's a beautiful thing.
Yeah.
Yeah.
mm.
That
Should
was
ask
one-
my doctor.
Yes, sir.
30 years ago I had that done. I got silicone elbows.
Oh
Ooh.
my.
It was an emergency situation.
You were way ahead of your time
Oh, yeah.
because elbows and shoulders are very recent.
They took one out and took it down the lab and actually constructed it.
Took a prototype, it 2 off.
That's impressive.
Got the other one out. Yeah.
That's we used to have a sister company called Proto Med, and we split off for liability reasons. We don't work with them at all anymore. We used to be co-located, but like cleft palates, they do a lot of cleft palates for kids around the world, and they used to have to open them up, measure everything, create a fix, close them up, create the fix, and open back up. Now they just take all that X-ray data, print a model, and then fit the fix to the model, and then they only have to open them up one time. I mean, it's really cool.
Well, I said that because a place out in Golden did.
Yeah, they're very good. They're a really good shop. Andy Christensen and his group, they do great work.
So is there technology, I'm assuming there is, for like 3D scanning?
Yes.
To, and then that can
Yeah,
directly
there's
convert to
I
3D
know
CAD
of
file.
a couple of guys that do it on the side, and there's a company called Advanced Coordinate Technology in Denver. They're professionals for scanning.
So if I want to do a bust, I go there and do a scan and then you'll thing it or.
Yeah, if it's a bust, I would go to someone like Elliot Simmons, who's a sculptor.
Oh.
And
right,
does
you just
scanning.
have them
And when you scan, you either get a non-modifiable or a modifiable file. So that's what you got to ask for. If you need to modify the geometry, you need different software than a typical Next scanner would have.
Oh.
I guess like art options, like somebody makes a sculpture and wanted to replicate it.
Yeah. But if you want to reverse engineer something like that, and you scan it and you want to add a third thing to it, then you've got to get a modifiable file, and that takes somebody like ACT to do, or John Irvin at Nico, or something like that.
Pretty amazing.
We take a break.
Well, thank you very much, Bob.
Thanks very much for having me. Enjoyed it.
you're obviously welcome to stick around if you'd like to for the second half. We're
Heck no.
okay. You can go home.
I got 45 minutes to get home.
Uh-oh.
And it's my birthday today.
Oh, if you'd known that, we brought you cake.
There you go.
They brought cookies.
No.
Well, we'll take a brief break. The restrooms are at the bottom of the stairs and straight forward. When we come back, we'll have a kind of open discussion and answer questions. Because with this many, I'm sure there are a lot of questions around the room that need answered. And share what you know so everyone else can learn.